Welcome to the Ordering Digits game. This game is suitable for students who have learned to read 5-digit numbers and is intended to help them gain a deeper understanding and how the value of a digit depends on its position in the number. The game can be conducted as a class competition between two groups, or the students can be divided into pairs, each with its own computer. The game includes 5 rounds. In each turn, the player will be able to move one of the digits in the goal of reaching a maximum number at the end of the game. Students who only have a basic understanding of the topic may choose a short-term strategy that can turn out to be ineffective at the end. In this demonstration, we will decide that the blue player will try to make a move that is best while thinking one move ahead, while the orange player will work towards the best situation at the end of the 5 rounds of the game. We'll see how this goes. In the beginning of the game, each team has the number 12,345. At any point during the game, we can click a gray circle to see the place value of the digit. We can click again to hide this. Let's start the game by clicking New Move. The app now shows at random an instruction for the blue player to move one of the digits 2 places to the right. We said the blue player will be thinking one stage ahead, so he or she will choose the 1. We click it, and look, it moves 2 places to the right. The digits 2 and 3 took its place. And we can see the visible gain of this move, moving up from 12,000 that the orange player still has to 23,000. We now click New Move for the orange player. The orange player must now move one of the digits 3 positions to the left. The orange player won't move the digit 4, even though we can go up to 41,000, but the 5. So the blue player is still ahead, and now we're in round 2. New move for the blue player. Thinking one stage ahead, the best move is to advance the 4. Note that in this case, if a student clicks the digits 2 or 3, nothing happens because they cannot move 2 places to the left. So let's click the 4, but before this, in class, we could call a student to the board and ask them to place a finger where they believe the new height of the column will reach. The change will be visible, but not dramatic. Now the orange player. The orange player must now move again one of the digits 3 places to the left. Let's choose to move the 4, even though this will actually lower his or her number in the short term. We're now in the 3rd round. New move for the blue player. Best option now is, of course, to move the 2, 1 to the right. And we saw a large visible gain. In class, we could say that the gain is most visible when the digit in the place of the 10,000s changes. Let's click it again to move back to the gray circle. And now make a move for the orange player. The orange player must move a digit 1 to the right. Let's click the 4. Now a new move for the blue player. The blue player must move a digit 3 places to the right. Note that the only 2 digits you can choose are the 4 or the 2. Obviously, the 2 is the better choice. And the move for the orange player. 2 places to the right. Now we will see how the long-term strategy of the orange player pays off. He moves the 1, 2 places to the right, and we will now see a dramatic change. The orange player takes the lead. The main objective of the orange player all along was to bring the 5 to this position, the position of tens of thousands. If the 5 could not be advanced, the orange player would advance the 4. The blue player will now understand the only way to pass the orange player is to also advance the 5. If this player is not able in the final round to bring the 5 all the way to the tens of thousands place, he or she will lose. But there is still room for luck if the player gets to move a digit 3 places to the left. Let's click New Move. And he's lucky! The blue player got to advance. In the last move, the blue player got to advance the 5 all the way to the tens of thousands. So in this game, luck does play a role. Now let's click New Move for the orange player. The best option is to move the 1. And the blue player still won. Regardless of which team won, the game strongly emphasizes how the value of a digit depends on its position. Let's click New Game. And we see we're back to the initial situation. We can also change this game to work with decimals. We click here, and look what happens to the numbers and the scale. So instead of 12,000, we have 12.345. The game is now actually identical to the previous one, but the students will think in terms of tenths instead of units and thousands. From our experience, the students enjoy this game and learn a lot from it, and we hope you too enjoy it in class.